Well, hello everyone, this is KP, the Math G once again. I have this figure drawn. I had to retrace it. My tracing skills are terrible, but at least you can tell what it looks like. The blue line is the graph of y is equal to alpha at x, which happens to be 1/4 plus sine pi of x, and I meant to put the other one up there. This one here is well, we can make it g at x. Alright, so g at x, I have a light blue and I have a dark blue, so g at x is equal to 4 raised to the negative x power. Alright, there it is. Alright, maybe I can turn to you where I can see, you can see me. Okay, so this is what we have here, these two functions here, and g is the 4 to the negative x. Alright, let me just write that down. I'm going to put it in black, I guess. Sometimes my markers are really not very good, so anyway, bear with me. And so what we are doing, this is the 2005 free response question 1. We are doing part C, and part C is find we want the volume of revolution about y equals -1. And like I said, I feel like this is a fairly simple problem. Maybe it is for me, maybe it's not for you. And oh yeah, by the way, just looking at this problem, when you have two curves, the first thing you had to do was find the points of intersection. And let's see if I still have them on my phone, and I don't know if I do or not. My phone I downloaded the TI-84 Plus on my phone, and I got a really nice calculator from it. Let me look. Let's see if I can find that real fast. Yeah, okay. Yeah, it still has it. Now, when I hit y equals, you have to put those two up there, and mine has y at 0 and y at 1. Yours probably has y at 1 and y at 2, or something like that. And I've got the -4x to be y at 0. Okay. Let me see if I can put that down. Y at 0. This one is actually y at 1. And and so you have to put them down first. I don't know, I know from the last video I probably tried to show you that. I don't know if you can see any of that, but that's as close as I can show you. That's what I have, okay? Alright, I don't know if you can see that, but anyway, that's what you do. You put them in, and then you simply hit graph. And of course, this is what the graph looks like. I already have it zoomed in. Alright, so I don't know if you can see that or not, but okay, that's about as good as I can show you. Alright, so anyway, it's like this anyway. And what you have to do is you have to find where they intersect, and on mine phone, I can just hit intersect and they will automatically show up on every place that it intersects. Okay, and so in this particular case, this intersection here is 0.1788822, 0.17822, and this one intersects at x equals 1. Okay, alright, so at x equals 1. Alright, so right here, well, x equals 1. X equals 1 right here. Okay, it's this intersection. And we have to know those to be able to do what we're about to do. We need to have that volume of revolution about y equals 1. So to begin with, remember that when we do volume, this is pi. Okay, we're integrating, and then of course we have r squared. Actually, in this case, we might have a big R and a little r like this, and then dx. Alright, and then we have to know what our limits of integration are, and in this case we know that they are from 0.17822 to 1. Alright, and that is what we need to do. Now, capital R is, we got to figure out how long that radius is. Let's make that partition here. All right, let's make a little down, all the way down to yeah, I had to make this -1. It's not the same distance as 1, but for the lack of board space, I have to do that. Okay, so all right. I don't have all the sophisticated equipment that some people on videos have, so I just make do with what I have, and I'm happy I have it. Alright, so there's that. Alright, and I always ask, how tall is this structure that I just drew? How tall is this rectangle right here, this isointerval that I've drawn here? How tall is that? Okay, well, anyway, we know that it's 1 unit this way. Alright, we know that, and from times past I've done videos on that, and you can look those up and you'll see out of one of my 105 and now 106 videos, you'll see that somewhere, probably a couple of times or more. Okay, how tall is this? Well, we know it's 1. We never say -1 because we're seeing how far in units it is. So from here to the x-axis, that's 1, and then here is the distance from here to here. Alright, so we were looking at this distance from here to here. We want all of this distance here, so this is 1, and then this distance here, right there, that is this alpha at x right here. Okay, this is y, which is, this is the y value here, y, how far up that goes. Well, y, a y distance, which is, in this case, alpha at x. This distance is alpha at x, and of course we are subtracting off this distance also from here down. We're subtracting off, let me erase this over here, get some room over here. We're subtracting off, okay, actually even further than that. This distance right here is g at x. Okay, alright, so we see, and also this side is 1. We might as well just, well, okay, 1 is 1, it doesn't matter. Okay, I know I'm trying to overemphasize something here, doing both sides of this. Okay, that's what I'm doing. Okay, on this left side we have 1 plus alpha at x here, don't we? Alright, this is going to leave this amount is going to be the whole. So from here to here is the whole. That's the whole. Alright, that's the whole from here to here. Well, how high is that? Well, this part is g at x, and then this part here to the right is 1. So 1 plus g at x is the whole, and 1 plus f at x is the whole thing. Okay? And that's what we're looking at here. Alright, so 1 plus y here, but this y is f at x. And then 1 plus this y is the whole that we're subtracting off, and that's g at x. So 1 plus g at x is the height of the whole, and 1 plus f at x is the entire length of this radius here, of the big radius. Okay? Alright, so that's why we do that. Alright, so let's see how we can interpret this over here, big R and little r. I think we've already got this down. Alright, I mean, let's stretch it out a little bit here. And we already know what the limits of integration are. That's good. Now what we want here is 1 plus f at x, and we're going to square that. Okay, remember pi r squared. Okay, and did I put just big R and little r? But actually it's r squared. Okay, alright, minus now 1, well, got ahead of myself, 1 plus g at x. Alright, and we're squaring that, and we're going to squeeze in dx here. This distance from here to here is delta x here. So we say dx here. Okay, because it's running along the parallel to that x-axis. Now if you can get that, you've got this. Okay, so 1 plus this y, which is f at x, the whole is 1 plus this y, which is g at x. So 1 plus g at x is the height of the entire whole. So once we get that, now you can do this. You can put it in case you don't know how to put it in on your calculator. You can put it in just straightforward. Okay, alright, you can put this part in 1 plus this part, and then minus 1 plus this part right here squared. Okay, and then block it all in, put it all together, and then dx on the end. If you know how to do it this way, alright, 0.17822 to 1, you can already do, since I already know that y sub 1 is alpha at x, I can do 1 plus y sub 1 squared, okay, like this, I'm sorry, bear with me, like that, minus 1 minus y sub 0 squared, and I'm going to show you what you do to get that. Okay, how you can do that. Once again, you could just put them straight in there, like that, if you don't know how to do it. But there is a way that you can. Okay, I'm going to back out, and if you see on your calculator there is a bar on your calculator, VARs. Alright, so I'm going to show you how to start this, and then that way you can do it. Alright, so let me see. I'm going to make sure it's on here so you can see. Alright, so if you do VARs, okay, go to Y-Vars, like that. Let's see, function, yeah, function. And then hit enter, and then you get your Y1, Y2, and 1. So if you already have y1 and y2, they have to already be graphed. Alright, and then you can just simply hit that y1 function. You can hit enter and enter that one first. So 1 plus, make sure you have your 1 plus in there, and then you can hit your y1, and then in your case probably y2. This would be y1. I've got y sub 0 on mine, okay, but anyway, you can do that and then do that again, but you got to make sure, okay, you got to make extra sure that you already have those. Well, I don't have them in that. Okay, so let me show you what I've got on my phone here. I've got them in opposite order on the calculator. See, I think I've already showed you this, but I'll show it again as best as I can show you. Alright, that's it right there. The 4 to the negative x is the top one. Oh, let me see. Alright, 4 to the negative x is the top one, and then the bottom one is, I got 0.25 plus sine pi x on the second one. Alright, I don't know if you can see that or not, but you need to already have that in your computer. And you got to see what order that you put it in, so you'll know which way to do that. Okay, so that's why I had to do y1 first minus y alt, because I put this one on top and then this one second. So there's my y1 right there, there's my y alt there. When I hit enter, okay, let me look at this. I did that, and okay, the answer to this is 4.558, which you could say 4.559. So it's about equal to about equal to my, I'm sorry, my pens are drying up. I need to throw away some of these and keep the good ones out. Okay, so this is about equal to 4.5887. So 589. I think I can do that. 4.5855. I'm sorry, 55. I don't know why I have an 8. 55. And then it was 8, 7, so now 9. Okay, there it is right there. Okay, that's my volume of revolution. Okay, it's going to be in cubic, so pi r squared, and then the rotation. Okay, so pi r squared, and you get an extra, that dx is that third dimension. Okay, and that's going to be in cubic units right there, but I don't think you even have to write cubic units. Okay, so 4.559 is the answer there. Get the idea. I mean, you have to be careful putting parentheses around this, but you can do it. Let me do it the other way too. All right, I don't have room here. I thought maybe it may help to see how this is done. Okay, if you want to go the long route, oh my goodness, what about that again? If you want to go the other route, you can simply do this. Alright, so we're going, it was 0.1 something. Okay, 17822, 17822 to 1. So pi, you could put the pi in front, and then you could put 1 plus. I'm thinking we're going to need several parentheses. Well, let's do parentheses. Alright, let's do parentheses. So 1 plus, let's see, 0.25, okay, it was this right here, okay, plus sine pi x. Okay, so what the idea behind this is make sure you have the same number of parentheses. We'll have that in the end. Okay, we're going to make sure that we have that. So minus, okay, so again, 1 plus 4 to the negative x, like that. Squared, by the way, all of this is squared. And then squared here, and then close. Let's see how many pairs of parentheses we have now. I have these two here, I have these two here, and then I have this one, these two way out here, and then these two here. So that has to match. If it doesn't match, then you know, of course dx here, then it's going to come up with an error. But you got to make sure that you have everything together here. Okay. Let's see. I'm thinking that this is. I'm not sure. Let me think just a little bit about it. This here. Well, these two. This is here. Maybe this. I don't know. Squared, and then of course. Yeah, I think we had to put, let's see, I'm trying to think now. I'm not just squaring this, I'm squaring the whole thing. So yeah, I need that. Alright, so I need that, and probably one more out here. Alright, so I just want to make sure that, I mean, I got so many parentheses, I know, I realize that. So this one, this pair here, this pair here, and then this pair here, that goes with that, and then I have this pair here, and then this one, let's see, I've got all of that, and then probably I need one over here, yeah, and then this matches here, I think. Alright, I think that's right. So now I've got this outer pair. I'm sorry, I'm taking so long to do just the parentheses alone. Alright, enter this, this, this. That should do it right there. I believe I'm right on that. I did do it the long way like that, but that's the idea. You get the idea behind it. That's the main idea. Let me see. I've got that already. Oh my, I have so many parentheses. So I actually have 3 sets of parentheses. Okay. Anyway, I believe you do get the idea behind this. I'm thinking that I have the right pairs of parentheses there. So anyway, you just want to make sure that you do have everything there. Yeah, okay, yeah, that everything is set here, and then you got, yeah, I think everything's right, and then once you do that, you still get the same answer there. Okay, and so that does work out just fine. I got the same answer doing that, but you got to make sure that your parentheses are correct when you first start. What you're trying to do, you're trying to close in the whole thing like this first of all. That's what I'm trying to do here. And then and then of course here I'm closing in this part right here, and then this part here separate from, I don't know if you need to do that, but I do. I did that. And then here, that should be enough there to make it work. But you get the right idea on that. Just make sure that you have the right pairs of parentheses when you do that. But that's the correct idea here. But once again, though, I'm saying that if you can get where you can do this right here, this saves a lot of time, because you're going to need it when you're taking that test. Okay, if you can possibly think to do that, right here, that will save you a ton of time. Okay, well that should help out. I hope that I didn't muddle too much around with the parentheses, so much there, but I hope this does give you the right idea. Again, 1 plus the top y here, and then the whole is 1 plus the lower graph here. Okay, so anyway, the lower y. Alright, so if you get that, you have that set up. At least you're going to get some points if you show this, I guarantee you. If you show this, and hopefully from there you will get the correct answer. But anyway, that's just showing everything. That is what you want to do. Okay. Well, anyway, this is KP the Math G. Again, if you will, you can subscribe if you haven't already. If you would like to make a comment, please do so. And if you would like to hit that like button, please do so as well. Again, I do appreciate you and your patience with me today in picking out these pens that write and everything. I just have all sorts of things I need to kind of clean up around here so that next time it'll be so much easier and better. But I hope this has helped you understand what you can do. I hope I've been a help to you. That's what I really want to do, is be a help to you on that. And anyway, I trust that you have gotten some really good stuff here from me. That's what I really want to do. Whether you subscribe or whether you give me a comment or do a like or not, this is the main thing that I want you to get right here, is to understand it. That's the main focus that I have for you. Alright, anyway, KP the Math G signing off. Have a great day.